Hey folks, how's it going? Today we're going to be looking at a really good trick that I use when I'm working with Kinect cameras or other depth sensors. And this common problem is that a lot of the time you want to have something like a depth map that you can either do blob tracking on or create some interesting visual effects. But the problem is that things like floors and walls ruin that depth map. Now, in this case, the interesting way we can approach this is actually by using the point cloud texture, which gives us X, Y, Z positions of where all of the different points are in space. We can actually then clean that up, use a couple of tricks that we know how to do with removing, different kind of clipping planes out of our point clouds. And then what we can do is re-instance all the points, and with something like this, use that Z depth to recreate the colorization of a depth map. So essentially we're taking our point cloud and recreating a brand new cleaned up depth map for ourselves. So in this case, I'm going to delete everything here, and I'm just going to start with my Kinect Azure little snapshot I have here. I just have a locked snapshot little image of a point cloud of me just standing in my room here. And you can see there's all kinds of stuff around me. And if I switch this over using the V key to the view as points mode, you can see that there's a ton of stuff on the floor that's being captured, and there's this whole back wall that's being captured. Now, a lot of times if you're just trying to use a raw depth image, especially if you're coming from a sensor like a RealSense that maybe doesn't have the Kinect's player index mode that helps you isolate the person, working like this can be really tricky. So we're going to use this point cloud and we're going to start cleaning it up. Now, the first thing I recommend doing is thinking about how we want to clip our planes. And oftentimes what happens, as we can see here, is that the view from the Kinect is going to be slightly rotated, whether it's in the left and right kind of direction, or whether it's a rotation on the x-axis. So you can see here, our floor isn't even parallel with the z-axis here. And that's, I think, the first step to making this an easy process. If we can reorient our world a little bit so that the floor and wall are kind of parallel with our main axes, it'll be really easy for us to create those clipping planes. Now, we have a lot of new operators that we can use in TouchDesigner for this. So I'm going to start with a point transform top. And I'm going to go ahead and plug my Kinect Azure into it. And again, I'm going to activate the viewer with A. And I'm going to switch to view as points mode, because this will make it a lot easier for me to see what the actual point cloud looks like as I'm rotating it. Now, the first thing I'm going to do is just kind of line up my viewport a little bit, just so I'm looking nicely down on the z-axis. And then I'm going to start to rotate my point cloud. So in this case, I have to rotate along the x-axis here. And as I rotate, I'm going to be readjusting my camera. And as I get to the point of thinking that, it's almost looking parallel with my z-axis here, I'm going to start shifting this back up so that I can kind of line up my floor with the 0 mark. So we can look in here and just keep raising that a little bit. And I'm going to try and ideally put my floor just under that 0 mark. So maybe a little bit lower. Perfect. So now that looks pretty good to me, and you can definitely spend more time, make this cleaner, make it more parallel, whatever you would like to do. But for our example, this is more than enough. Now, once I have these planes aligned, what I can use is a really simple GLSL shader that is just really only about 2 lines long to say, hey, you know what? Take everything that's below a certain value on this axis, delete it. Take everything that's beyond this position on a certain axis, delete it, and that'll essentially delete our walls and our floor. Now, if you've never done this before, don't worry, we're gonna go pretty slow, and it's really only about 2 lines, but there is another YouTube video on our channel called GLSL clipping planes. If you take a look for it, you'll see it pretty recently. So I'll go ahead and make my GLSL top. And I'll go ahead and connect my point transform to that first input. And I'm going to open the pixel shader so I can edit that code. Now, in this case, what I'm going to do is just delete the first few lines. We don't need those comments. I'm going to delete on line 5 the little comment markers, because we'll just use this stock kind of boilerplate code to sample our input. I'm going to delete this line 6 because that's just setting everything to white, which is what we see by default here. And then what I can do is hit save, and I know this is working because I see it coming out of my GLSL here. Now I'm going to switch back to this, and what I'm going to start doing is doing my if statement checks. And this is a really easy way where we can say if the value of a point on our Y channel here, because first we're going to do our floor clipping, if the Y value is less than 0, put that point somewhere else, essentially delete it. So if we're going to do that, we can start by typing if, open a set of parentheses, and we can say color dot G, because remember in this case our Y coordinates are inside of our G channel, and we can say is less than, and let's just start with 0.0, and then I'm going to open a set of curly brackets here, and I'll indent and type color equals vec4, and in this case, just for simplicity, for all the pixels we're not going to use, we're going to put them at 0.000. So I'll just say 0 point and put a colon on the end. So this is essentially taking the incoming color value that we have, which holds our XYZ position. If that height of that point is below 0, which is going to be our kind of clipping plane for the floor, basically just 0 at that point. Make it black, erase its data. It's not worth us actually visualizing. So I'll go ahead and save this. And what we can do is look at the output here. So I'm going to put a null top, connect those two up, and then I'm going to switch my null top into the viewer by points mode, view by points mode. That's what it's called. And you can already see, not bad. You know, we've deleted big chunks of the floor, and we still have things like the feet of the person in there. But I would say I could probably go a little bit more aggressive on this. And what I'm going to do is decrease or increase my position here. So maybe 0.1. Now we can see the floor is totally gone, but so are my feet. So you could expose parameters for this if a little bit more skilled in GLSL. 0.5 looks like I'm getting a little bit of foot, so let's just say 0.25 for this example. So now I still have my feet here, but I don't really have any of the other floor bits hanging around. So that should be pretty good for now. And what we can do is the exact same process, but instead of looking on the Y channel or the green channel, we can look at the Z channel, which is going to be our blue channel here. Now it's important to note that because of how the Kinect kind of gives us this data, we can see actually on our axis here, normally in TouchDesigner, we're used to putting objects in 3D in the negative side of the Z space. But in this case, it's important to note that our point cloud is actually going towards the positive side of the Z space. And this is going to be important in two areas. The first is going to be right now when we're going to clip it. And the second is going to be knowing which direction to point our camera. So let's start with our clipping here. I'm going to open up my shader again. And I'm going to do the exact same process, except instead of looking at color.g, I'm going to look at color.b. So I'm going to say if color.b. Now in this case, remember, we actually have to do a greater than check because as the point cloud progresses, that Z value is increasing. Now you could do a lot of different steps to maybe make this easier, such as normalizing your point cloud in the steps previous. But in this case, I'm working quick and dirty and I just want to clip that back wall out. So what I'll do is I know 1 is here. I could probably guess that 2 is about here somewhere. So maybe 2.5 should start clipping that back wall out. So I'll say if color.b is greater than 2.5, and we can repeat that same process, color equals vec4 0 point and a colon. Now if I go ahead and save that and take a look again, wowzas, that is so much cleaner already. We can see it's basically eliminated all of the junk on the wall, even got rid of those ceiling chunks I think that were in there. We have a tiny bit that remains, and we could even make this probably a tiny bit more aggressive, but that also depends on your situation. If we make this clipping plane more aggressive, that means the user can't really step back any further. So we'll say for our purposes that already night and day difference. We've cut most of the floor out. We've cut most of the back wall out. Now we want to create a new depth map from this data. Now, the easy way we can do this is through instancing, because like we saw at the beginning of this, what I'm going to do is take all of this point data, instance it, but then the trick is I'm also going to use the value of the Z position as the brightness of the actual instance. So that way you still get that same effect that you would with a depth map, where you can say anything that's very bright pixel is closer to the camera, and things that are darker or close to black, those are farther away from the camera. So we can get that set up pretty easily. So I'll start by making my geometry comp here for my instancing. I'm going to go inside of it, delete the torus, and I'm going to make a rectangle SOP. Make sure to turn on the render and display flags. And I'm already going to turn the size down to something like 0.1. Generally, when I'm instancing, I don't like to go much below 0.1 because crazy things start happening in the universe, especially in simulations when things get very, very small or very, very big. So if that's still too big for my instancing, what I'll actually do is I'll scale up my point cloud to make these fit, which we're going to see in a second. So we have our rectangle set up. I'm going to go to the instance page of that geometry comps parameters, turn on instancing, and I have my null here, so I can just go ahead and drag and drop that onto my translate op. And I'm going to set my TX, TY, and TZ to RG and B. And we can definitely see that that is looking a little more chunky than I would like. I'd like a little bit more definition in there. Now, like I said, instead of actually going back and shrinking my SOPs any further, I'm actually going to scale up my point cloud size, which is really easy to do. What we'll do is right click on the wire here in between the GLSL and the null. We'll click insert operator, and we're going to find the math top, which math chop was already one of my favorite and most used operator, and math top is quickly becoming one that I use all the time. So what we could do in this case is go to the multi-add page of parameters. And as I'm watching my instancing setup here, I'm slowly just going to turn up this multiply value until I get the desired kind of density that I would like. And in this case, since we're aiming towards making a depth map out of it, we actually want it to be tighter and more compressed. So for example, something like this, where there is actually a lot more space between the points, might not be good for that depth map style of usage. So we might even actually keep this a little bit more dense so that once everything renders, we essentially get these big black and white blobs. So something like this, maybe even, we'll take this down a little bit more. Let's say 10. If we multiply it by 10, we still get this full textures of where things are, but we still have enough definition without a lot of overlap. So we've got that set up. Let's quickly set up our rendering before we actually colorize these instances. So we know that the render is going to need a camera comp. I know that I'm going to need a render top. And in this case, what I'm going to use is a constant matte because I don't need lighting to affect this depth map. I want everything to just have the color in the render that matches the color of my data. So what I'll do is I'll grab my constant matte, drag and drop it onto my geometry, and choose material. Now this is where the second important time to remember the axis that we're looking at here. Remember when I said earlier, our point cloud is pointing on the positive of the z-axis here. And by default, a lot of the times we put everything on the negative. So our camera is actually looking down the negative z-axis here. So what we'll probably have to do is rotate this around on the y-axis and essentially spin it around 180 degrees so it's looking down on the negative on the z-axis. Now, once it does that, I'm quickly just going to kind of translate this around a little bit just so I can center a little bit better on my information here. And one thing I also recommend in this is to probably go back to your Kinect texture coming in, check its resolution, Now you can play with this for different effects, whether you want to essentially upsample and make a larger resolution depth map, but in most cases, I would probably end up using a resolution that matches the actual size of my data coming in. So in this case, I'm just gonna set my new depth map to 640 by 576. Go over to my render on the common page, 640 by 576. And then I'll continue to finish adjusting my camera position a little bit, just so that I can really fill up my viewer with all of that yummy, yummy data. Great, so that is gonna work for now. So I've got my data instanced, even just like this. Could even be helpful for a lot of folks if you're doing something like maybe trying to blob track people that are moving inside of a Kinect space, and it's a really simple space. You know, for example, I have this table here, but if this was actually a clear open space, you could probably be a little bit more aggressive on the floor, a little bit more aggressive on the ceiling, and you could very easily do a nice blob tracking and just see exactly where people are as they're entering or exiting the space. But in this case, we do want that Z information represented in the color. So what we're going to do on our instancing setup, on the instance 2 page, we essentially need to generate new RGB values for each one of the instances based on its depth. Now it sounds a lot harder than it actually is, because what we're going to do is just take the output of our GLSL material, rearrange our Z depth data so that it gets changed from the world space that it's in, because remember, this is actually, let's see here, we'll look at our GLSL itself. The range is going to be between 0 and, like we saw, somewhere around 2.5, 2.6, but we need to actually range that down into a 0 to 1 range for our colors. Now that's very easy to do, because what we can do is make another math top here. And I want to split a separate chain off of this so that it doesn't mess with the positions that I've already instanced. And in this math chop, I'm going to go to the range page. And I love this new range page because it allows us to work on every channel individually. Now in this case, since we're working with our Z depth, we're going to be working on our B channel. That's really the only channel we're going to be worried about. And I know in this case that I'm clipping from 2.5 to 0. So what I can actually say is, give me from range of 2.5 to 0 and represent that as a range of 0 to 1. Now, if you have trouble visualizing this, a few good ways to think about it. We know that we want the farthest away objects to be darker, and we want the closest ones to be brighter. That's why we're ranging from 2.5 to 0 instead of going from 0 to 2.5. Because if we did that, then we would actually have the closest objects to the camera be the darkest ones, and the farthest one would be the brightest ones, which in most cases is not what people want. So in this case, by putting our farthest world space coordinate first and our closest one second, and then mapping that to 0 to 1, we're essentially saying closer things are going to be bright pixels, farther away things are going to be dark. And we can even come back and play with this in a moment just to kind of tune the visual for our use case. So what I'll do finally is put another null top here, connect this math to it, and on my geometry here, where I have the color op, I'm going to grab this null 2 and drag and drop that onto there. Now in this case, because remember we said our Z depth is the only information that matters, we aren't going to map, you know, R to R, G to G, and B to B. We're actually going to take the B channel and map the B channel onto all of the RGBs. So we're going to say B to R again, and B to R one more time. And you can see once I do that, already I'm starting to get that colorization. I can see things that are close to the screen are brighter, things that are farther away are darker. Now, this is where I was saying we'll probably come back to play with that range, because in this case, we don't actually have anything that's really close to that 0 mark. Really where our visualization starts is probably, actually, let me switch over to the GLSL here before it gets ranged up. Looks like around 0.5, 0.6, that's where the closest objects are. So what we can do is go to our second math here and say, instead of going from 2.5 to 0, while we're even watching our render here, we can start to lower this, or actually increase this value. And you can see as we increase it, things that are closer are getting brighter and brighter. And then you can start to make decisions creatively about how close do you want something to be, or how far do you want something to be before it's detected as a fully white pixel. For example, if you want to make the range really big because maybe you're working on an effect where the depth really plays a role in it, you could keep this a wide kind of range, and that way you'll get a nice full gradient of black to white. But if you're kind of more interested in just picking up things that are in a specific range, you probably want to have less range and a bit more bright pixels. So for example, I could do something like this, where from 1.9 to 2.5, I can clearly see where things that are close are, and I still have just a tiny bit of things that are far away, which I could either further cut out with just some top processing, or just add into the visual in some way. So just like that, with really a handful of operators, a lot of these new and fun operators, we went from a fully 3D point cloud with lots of walls and floors and noise and kind of like a weird orientation. We straightened it out a little bit with our world here with a point transform. We used 2 lines of GLSL, maybe 3 technically or 4 technically, to clip the floor, clip the back wall out. And then we just used 2 math tops to essentially increase the size of our 3D space so that we could instance it a little bit easier. And then we took the blue channel and basically rearranged it into a 0 to 1 range so that we could use those as the colors of our instance. And lo and behold, we essentially have a brand new depth map, very much cleaned up, especially if you're working with sensors like maybe Z cams or RealSense cameras that don't have the player index built in like the Kinect does that automatically cuts out the person. This can be an incredible technique for cleaning up some of that data. Enjoy. Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.